I'm going to go ahead and introduce George Christensen, who is a retired physician. He is a clinical professor at the Loma Linda Medical School, where he has received numerous teaching awards, including School of Medicine Teacher of the Year. So let's give a round of applause for George.
Thank you, Sarah. So, I am the bad cop. So, I'm the one, just make sure this works.
Yeah, down here up.
Okay. So I'm the one that gives you the scary news, and then the other two give you the better news about what you can do. But the reality is, yeah, that microplastics do make lousy presents. At the end, my last slide, I will tell you of a very much better kind of present that you can all be giving. This talk is going to be about microplastics and human health, which is actually a much smaller body of information than what I'm not going to be talking about, which is all the information that has been accumulating about microplastics and all the other animals on the planet and affecting them, particularly in the ocean. So, first, oops, just a sec. I want to mention, so where do these microplastics come from? Well, obviously from plastics. That kind of makes sense. But you may not know that many of you are wearing plastic clothing. So all synthetic textile fibers, polyester, rayon, things like that, are petroleum-based products that gets treated in the environment the same as any other kind of plastic. And in other words, it does not break down, it breaks up. These are things I just heard about. They're nurdles. They're used in industry. I don't know what they do, but they are another source of microplastics. And then the thing, again, I didn't know about, but somewhere around 80 to 90% of personal care products, lotions, face creams, toothpaste, and chewing gum have plastic in them. And in particular, in the lotions, they actually put micro beads, which are kind of halfway already there to being a microplastic, and those can break down. We'll talk a little bit more about that. Now, at the very end of our 3 talks, there will be an information slide, which will be lots of tiny print. Just take a picture of it. It's all these websites tell you how to find plastic-free chewing gum, plastic-free products, things like that. So we'll have that at the end. So, the reality is that plastics and the plastics industry has been booming. Frankly, the petroleum industry is now shifting their focus increasingly over into plastics because they see it as a place of higher profit margin as the global demand for oil reduces, hopefully. But that's not, this has been happening for really, sorry. So, plastic consumption has quadrupled in the last 30 years. Just in the last 20 years, more than half of the plastics ever produced have been produced just in the last 20 years. Now the problem is that plastics don't break down. They can be in the environment for 400 or more years, but they do break up into smaller and smaller pieces. And so a little bit of definition here. And sorry, this is metric, but it doesn't make sense to talk about micro feet. So these are, so a meter is 3 feet-ish, a millimeter is 1,000th of that, and microplastics are defined as 5 millimeters or smaller. Most are way smaller than that. A micron is 1/1,000,000th of a meter, and if it's anything smaller than 10 microns, can slide easily into the interior of cells, human cells, animal cells. And a nanometer is 1/1000,000th of a meter, and just to give you a feeling, DNA is 2.5 nanometers. Human hair is about 20 microns, just to kind of give you a feeling. So this is the size scale we're talking about. Now, in terms of medical concern, this has really shot up. So if you look, this is from a search that I used for most of this talk. So this is the National Library of Medicine search engine called PubMed. It's clever. And in 2018, if you just search for microplastics human health, in 2018, you pull up 54 articles. This year, as of November, there was over 500 articles. Now, anytime you see something like this, it means three things. One is the researchers are getting both interested and concerned. Two, their funding sources are also concerned, because that's what pays for the research. And three, it's too early to have many firm conclusions. You know, when it's just at the beginning of looking into something, what you have are far more questions than answers. And we'll see that. But there are some things I do want to point out to you. So, the first thing, and this is what a lot of the articles published to date about human health have just been saying, where are they? Are they in various organs, the microplastics, et cetera? And to date, they have been found in breast milk, in lung tissue, placenta, and we're going to talk more about placenta toward the end. In the baby's first stool, called the meconium. So the baby's first stool begins developing 6 months in gestation. So what this really means is what the baby was getting in utero and depositing in their GI tract. It's in the blood, and frankly, if it's in the blood and it's tiny, it'll be everywhere, because it'll get everywhere and it can slide into the cells. In sputum, which is stuff you cough up, I told my wife I should put just blue D up here, but, and in colon tissue. Those are the main places it's been found so far, but frankly, it's going to be in pretty much every organ. Now, how do we get microplastics into us? Well, there's three main routes, and they're not a big surprise. One is that, one is that we swallow them. So here's a slide showing people who, this is their stool, and you know, holiday time is not the time to talk about stool, but still, it's one of the easier places to go and look for microplastics. So in this study, these are people who mainly drank boiled water. I think this was from Indonesia, where maybe they have to boil their water, but and these are people who mainly drank bottled water, and they had more microplastics. Similarly, those who mainly did home cooking versus takeaway, they had more microplastics in their stool. So this shows that, you know, the kind of sources that we would think of actually make a difference in how much you get into you. We breathe them in. The microplastics break down and down and down until they become dust, and they are all in, you know, basically they're in this room. Fibers, microfibers have been found in Antarctica. So they blow all over the world. And so this is a, I keep doing that. This is a polyurethane, actually microfiber, found in lung tissue. It's like, polyurethane? I mean, I only use that for like varnishing things. But it turns out that they make fibers out of it that are like water repellent for like rain slickers and things like that. Now here, we're looking at the, this is a study that looked at facial scrub, which already has like 30 micron size microbeads on purpose, but what they wanted to ask is, do those break down in the actual tube just by being bumped around? And so this is an electron microscopy picture. This is just 1 micron, which is like really little. So anything smaller than that is a nanoplastic. And you can see there's lots of these teeny tiny nanoplastics inside the facial scrub that would easily slide through your skin into your body. One of the things, I won't go into too much depth, but in cell tissue studies where they sprinkle microplastics and nanoplastics on, one of their findings is the smaller the particle, the more damage it causes, and probably because it can insert itself in more places. So this is of concern. Now, again, the point that a lot of microplastics are microfibers. Even in the ocean, as much as 60% may be microfibers. And where do those come from? They come from textiles. In the textile industry, the fast fashion industry has shot way up in the last 20 years, and we're producing way more garments, and we're throwing away way more garments than ever before. So here's an example in the study where they were looking in the colon and when they were looking in the lung. 62% of all of the fibers, of the plastics that they found in the lung were fibers, and in the colon, that was almost everything was fibers. Now, in the other studies I've looked at, probably this is the more common figure, but around half are fibers. So, think about maybe not buying Uncle Joe another shirt when he has a whole closet full, because they end up just being thrown away and they get into the environment. So we've established that microplastics are in us in all of these places. Obviously, the real question is, what are they up to? Is this a problem? So this is, in looking at what is being published to date, you find a whole lot more of these kind of articles. And what these kind of articles is medical hand-wringing. This is concern. All of these articles about, could it be in the brain? Could it be causing neurotoxicity? Could it be causing obesity? Could it be causing cancer? Could it be causing developmental abnormalities? Could it be causing changes in the microenvironment, bacterial environment in your GI system? None of these are human findings, but they're human worries. And that's what these articles are sort of putting out to their colleagues, that we need to be watching for this. And what are they basing these worries on is this. So you do not need to memorize this slide. But this is from a review article that pulled together all the articles that they could find as of this year. By the way, I'm referencing about 16 total medical articles. 12 of them were all in the last 2 years, and some of them just within the last few months. So this was just within the last few months. This is all of the findings in mammal studies, rats and mice. And there's a lot of technical abbreviations and things on this. The main thing is so this is where they gave microplastics, MPs, or nanoplastics, NPs, and they either inhaled it or drank it. And where all the different organs, where they found not only that it went to, but it caused functional damage of one kind or another. And so brain, lungs, spleen, kidneys, intestines, testes, in utero, placenta, ovaries, liver, heart. Based on these kind of findings, that's what's stimulating the surge in, oh my gosh, could this be happening in us as well? And particularly as the amount of plastics in the environment is just going up and up and up. But have there been any actual findings, not just that they're present, but they're causing something in humans? Well, I looked through all 501 of those articles that were published this year, and I looked at all the review articles I could find for the previous years, and I found 2 articles that actually showed an effect in humans. And of those 2, the top one was really hard to draw conclusions from. It's kind of an iffy study. So I want to do a deep dive in the only study, really, so far, that has shown some effect that may well be meaningful in humans. So we're going to do a deep dive into this study, and you can see it was published in somebody that uses British language, so it's fetal instead of fetal, but it actually is a group in Iran that did this, and what they did was they got 43 mothers, and one of the ways that this study becomes easy to do is the fact that most mothers really don't take their placentas home with them. So if you go and ask them for them, they're pretty much likely to give it. I mean, they're not like coveting it. And so they got 43 mothers, and they did a survey of lifestyle factors. That's one thing. They looked at their placentas very carefully, slicing them up for microplastic particles. And they looked at a couple of aspects about the newborn babies. Not a whole lot, but a couple. So this is some information. They split it into two groups. One group is normal birth weight, and then there's low birth weight. Now, low birth weight, by definition, is babies that are in the bottom 5% of size. 95% of babies are bigger than them. You can see right away there's a little bit, eyebrow raising when 30% of the babies were in the under 5% category. So I'm not sure exactly if this population is representative, but it's the only one we have, and it's a small sample, but we should still look at what they found. So there were, the babies were not small because the moms were either teenagers or older people. That can affect it. They weren't small because of being born too early. They both had almost 40-week gestation averages. But the average weight here was 4.6, and this was 7.2. Now, I would personally like to strongly assert that just being small isn't necessarily bad. And so, I'm like under third percentile. But the other thing that they looked at with babies is this thing called the APGAR score, which is assessed at 1 minute and 5 minutes after birth. It's a general measure of robustness and wellness. It measures respiration, heart rate, activity, appearance, things like that. And you come up with a score, and the maximum score is 10, you want it to be over 7. And in fact, I mean, even the small babies averaged over 7, but not much over 7. And so whereas the full birth weight babies were in the 9s. So I would still regard this as concerning. And the authors posited that the microplastics, well, actually I have to show you the next slide. So when you look at and you divide it into these two groups, and then you look at, so now we've looked at the babies, now we're gonna look at the placentas. This is the difference between the microplastics found per placenta between those two groups. So in the normal birth rate group, out of those 30 placentas, only 4 had microplastics in them, and that was a total of 6 particles. In the 13, again, it's a small number of low birth weight, there were 302 particles in those placentas for an average of 23.2 per placenta. And this is pretty eye-popping. Now, this is the only study, it's a small number, it needs to be replicated before we can really take this to the bank, but if you know anybody that's pregnant, I would, well, tell them something that I'm going to tell you in just a minute. Now the other question is, so now we've looked at the babies, we've looked at the placentas, let's look at the lifestyle factor survey. Where might these particles have been coming from? Now, it wasn't a super extensive survey, but what they did find was, just like that stool study, if you look at bottled water and you look at mainly eating takeout, the percentage of mothers who mainly used bottled water, 66% of normal birth weight, 92% of small birth weight, 47% mainly takeout, 77% small birth weight. And they found that, like eating takeout or eating bottled water, I forget which was which, but one of them, if you just look at that, the placenta was 8 times more likely to have microplastics in it if they were on the upper end of using these things, and 12 times more for one of the others. So this is, again, a real concern that the environmental exposure that we are receiving may well be having a meaningful impact in terms of microplastic accumulation. Merry Christmas. So now it's not just bottled water and takeout containers. This is another study from China, and they did not look at babies, but they looked at the other two, a survey of lifestyle factors, and again, they looked at the placentas. And what they found, this is another very small study, literally just came out this month. And the one I just showed you came out in September. So this is really kind of new stuff that hasn't really had a chance to be double checked. But what these people found was that there was a clear increase in particles in the placentas of mothers who at least twice a week used a scrub cleanser or toothpaste. I don't know why they didn't say one or the, anyway, so one or the other. Hot food held in plastic tableware. And I think the heat is probably a significant factor, again, with takeout containers. Ate fish or shellfish, we know there's a lot of microplastics in the ocean. You know, little fish get it, little plankton get it, and then little fish get it, then big fish get it, and then we eat it. And so this is not surprising. Drank more than 2 liters of water a day, or drank tap water as compared to purified water. Many studies have found microplastics in tap water, bottled water, just about every place they look. But the more you encounter plastics, the more likely you are to have it. In this case, in the placenta. So, this is, you know, when you think about, well, what can I do? You know, it can be overwhelming. These two pictures are from the internet. This is a wave of plastic. This is a pile of plastic in Chile. But this one was a picture I took at Costco. Once you start thinking about plastics, going to Costco is a very discouraging experience. There's just plastic everywhere. And so really, what can one person do? Well, I submit to you, that's the wrong question. Really, this is the question. What's your legacy? Is this going to be your legacy? What's your legacy? And what I mean is, so this is Hudson Walker, my first grandchild. He was born not quite 2 months ago, so I had to work his picture in somehow. But he's going to be, so what happens with climate change? It's very much like putting a cake in a 350 oven. Okay, that's where we are right now. And if you look at that cake 5 minutes into the time you put it in, it doesn't look that much different, so there's not much change. That's where we are today in the climate change picture. There's already more CO2 in the atmosphere than there has been in 3 million years. It's gone up really fast, and the climate hasn't even caught up with that. So it's like 5 minutes into baking. He's going to be 50 in 2072. He's going to be 60 in 2082, may have grandkids. What is he going to tell his grandkids about what his grandpa and grandma did way back in the 20s? And I want them to be able to hear that we were one of the ones who tried. I don't know if what I'm doing is going to make a big difference or not. That's not the question. The question is, I want to be one of the ones who tried. I want him to know that we are one of the ones who tried. And that, I submit to you, is the very best present you can give this holiday season. Thank you.